In problem 3, it says planetary motion. Kepler's third law of orbital motion shows you how you can approximate the period p in Earth years that it takes a planet to complete one orbit of the sun. Use the function p equals d to the 3/2 power, where d is the distance from the planet to the sun as an astronomical unit, AU, which is approximately 93 million miles, or the distance from the Earth to the sun. How many Earth years does it take Mars to orbit the sun? Wow. So pretty much here's what we know. An Earth year is 1 year to us. They're using the letter P to describe that. What they're asking us is how many Earth years does it take for Mars to go around the sun? So all of that stuff pretty much to say how many years does it take Mars to orbit the sun? Well, they gave us an equation, and let's see what we can plug in. Look at the picture. Can you see that here's the sun? Here's the sun, and here's Mars. How many astronomical units is it away? It is, let's write P equals 1.52 astronomical units away. That's what D is, by the way. Now, I know you might be questioning, what is the astronomical unit? Well, 1 astronomical unit is how far we are from the sun. We are 1 astronomical unit away from the sun. Mars is 1.5, so it's like 1.5 of us. Okay, now we're going to take this to the 3/2 power, excuse me. Now, because there's no real pretty way to write this, we're just going to say, well, we know that's the square root of 1.52, and we're going to take this to the 3rd power. So you don't have to use a fancy calculator or anything, okay? You can take the square root of 1.52, and then what you're going to do is you're going to raise that. Here's your exponent button. You see it? Looks like a little up arrow. You're going to raise that to the 3rd power. So you get that it is, and let's put approximate here, 1.9 Earth years. It takes 1.9 Earth years for Mars to orbit the sun. So, almost twice as long for Mars to orbit the sun. Alright, let's keep going on. In this chart down here, it pretty much says that all your old rules, and take a moment if you want to look back, all of the rules that we did here at the very beginning, all of these rules apply even when you have fractions. That's what that chart says. So, let's see how good you are. Problem 4, combining them. What is the 4th root of x third over the 8th root of x squared in simplest form? What I want you to do is follow steps. And this is whenever you see simplest form combining radical expressions. Ready? That is x to the 3/4 power. So step 1, change to fractions. X to the 3/4, there's your step 1, change to fractions. X to the 3/4 over x to the 2/8. Now let's go ahead and fix the bottom. That's x to the 3/4 over x to the 1/4. Now I would ask you guys, because I'm weird, I would say, where is the party at? And you would tell me, well, it's bigger on the top. Alright, so we are going to do 3/4 minus 1/4. And what are we going to get? 3/4 minus 1/4 is 1/2. So that means I get x to the 1/2. When they ask for it in simplest form, I expect you to put it back into a radical. Moving on. What is the following in simplest form? Alright, step 1, change it to a fraction. This is 3 to the 1/2. This is 3 to the 1/4. Because they're on the same level, I'm going to add 1/2 and 1/4, and I will get 3/4. This is for the exponents. That means I have 3 to the 3/4. Now put it back. That's the 4th root of 3 to the 3rd, which is the 4th root of 27. Because 3 cubed is 27. Part B. Change it to x to the 3/2. Change this to x to the 2/3. I would ask you, which one's bigger? Where's the party at? At the top. That's where your answer is going to end up at. So for your exponents, I do 3/2 minus 2/3. 3/2 minus 2/3 is 5/6. You guys don't know how to work with fractions. You're in a lot of trouble here. Alright, so this equals x to the 5/6. Do not leave it like this. Put it in a radical to finish it off. Try setting up the next one without looking. Alright, did you change 7 to 7 to the 1, square root of 7 to 7 1/2? Did you change the cube root of 7 to 7 to the 1/3? They're on the same level, so for my exponents, I'm going to do 1/2 plus 1/3. 1/2 plus 1/3 is 5/6. That is going to combine together then to 7 to the 5/6 power. You're going to then make that the 6th root of 7 to the 5th. And you will not leave 7 to the 5th as 7 to the 5th. I'm trying to get a good angle here. You will change that to the 6th root of 7 times 7 times 7 times 7 times 7. 16,807 is your final answer. Alright, in the bottom, they discuss different ways for simplifying numbers with rational exponents. I will tell you right away that I prefer method 2. I found that students work much better with method 2. Let's talk through the steps. They have 6 to the negative 2.5. Well, they made it a fraction at negative 5/2. Then, because it was negative exponent, they moved it to the bottom. Then they made it the square root of 16. They knew that the square root of 16 was 4, and they know that 4 to the 5th is 1024. Now you guys might tell me, Mrs. Al, I can just put that in my calculator. Well, that's great. Good for you. If you don't show me the work, I could care less how good you are at typing into your calculator. You have to understand this. If you don't, you're really going to struggle when it comes to any other math class above this. Alright, let's try it now. So we got negative 32 to the 4/5 power. Well, let's start just like they did in method number 2. Let us go ahead and rewrite it as the 5th root of negative 32. And then when we're done with that, we're going to take it to the 4th power. The 5th root of negative 32 is negative 2. But we need to take that to the 4th power. Negative 2 times negative 2 times negative 2 times negative 2 is a positive 16. Don't show me the work, won't get the credit. Part A, got it? 5A. All right, you see the negative exponent? It needs to go to the denominator. So we'll do 1 over 32 to the positive 3/5. Negative exponents, move them. That's 1 over the 5th root of 32. And when we're done with that, we're going to cube it. That's 1 over the 5th root of 32 is 2. And we're going to cube it to get 1 over 8. Part B. Alright, we're going to get the, no negatives, so you don't have to deal with it, the 4th root of 16, and then we're going to cube it. The 4th root of 16 is 2, then we cube it to get 8. Part C. Change it. Okay, two things, ready? Negative first, let's move it to the bottom. 1 over 9 to the positive 3.5. Okay, change to fraction. That's 1 over 9 to the 7 over 2. Okay, keep going. That's 1 over the square root of 9. And then we'll take it to the 7th power. That is 1 over 3 to the 7th power. That's 1 over 2,187. Example 5. When you have exponents on the inside with a parenthesis and then an exponent on the outside, you're going to multiply. So this becomes 8 squared times 3 over 2. This becomes 8 to the 3rd, which ends up being 512. I must see this step. Moving on. This is 7 to the 1/3 times negative 3. That is 7 to the negative 1. Negative exponent means move it to the bottom. That's 1 over 7 to the positive 1, which is 1 over 7. Okay, this is 1 over 14 times negative 7 equals 4 to the, what's 1/14 times 1/14 times negative 7? Well, that makes a negative 1/2. Okay, guys, negative exponent. Move it to the bottom. That's 1 over 4 to the 1/2. That's 1 over the square root of 4, which is 1 over 2. Moving on. This one's a little tricky. Do not distribute first. Put that in. Do not distribute first. Let's simplify first. 49 to the 1/2 is 7. 25 to the 1/2 is 5, because it's the square root of 49 and the square root of 25 to the 3rd. Well, that's 7 minus 5 is 2 to the 3rd, which is 8. $15. See your negative exponent? You move it to the top. When I move it to the top, I get x to the 3/4, x to the 2/3. That means I have to add. So I do 3 over 4 plus 2 over 3 equals, well, that's 17 over 12. That becomes x to the 17 over 12. Moving on. Negative exponent moves it to the top. So I get y and y to the positive 1/2. Well, add your exponents. So 1 plus 1/2 is 3/2. So you get y to the 3/2. Now what we have not done on these two is simplify, which we need to do. This becomes the 12th root of x to the 17th. If you want to make it even better, you can pull out one group of 12, and how many will be left over? 5 of them. Let's make sure we fix this one. That's the square root of y to the 3rd. You can pull out one group of y and have one group of y left. 23. 23, let's go ahead and let's write down this set of directions. I'd like you to write in exponential form. So that's going to be 7 times x to the 2/3. So you simply write that as 7x to the 2/3. The next problem, do the same thing. Write in exponential form. That's -8 t to the 1/3. That's all. Alright, we'll get the rest done in one more video.